Hello students, and a very warm welcome to our first chemistry class. Today we're diving into Chapter 1, Fundamentals of Chemistry. This is the perfect starting point for your journey into this amazing subject. In this lecture, we're going to break down what chemistry actually is, discover why it's so incredibly important in our everyday lives, and learn how we classify all the different kinds of matter that make up our world. It's going to be a fun and informative session, so get ready. Let's begin. So, what is chemistry? In simple terms, chemistry is the branch of science that studies matter and the changes it undergoes. But what is matter? Well, look around you. The chair you're sitting on, the water you drink, even the air you breathe, that's all matter. Matter is anything that occupies space and has mass. Chemistry is the science that explores what this stuff is made of, what its properties are, and how it behaves and changes when it interacts with other stuff. It's like the ultimate instruction manual for the universe, from the tiniest atoms to the largest galaxies. You might be wondering, why should I care about chemistry? The answer is, chemistry is everywhere, and it plays a massive role in our daily lives. Think about the medicines that help you get better when you're sick, that's chemistry. The food you eat and how your body converts it into energy. That's all thanks to chemical processes. The detergents that clean your clothes, the plastics in your phone, the fuel that powers cars, and even the cosmetics you might use, they are all products of chemistry. Our own bodies are incredible chemical factories, constantly running millions of reactions to keep us alive. Understanding chemistry helps us understand the world and ourselves on a much deeper level. Now, chemistry is a huge field, so it's broken down into several branches to make it easier to study. Let's talk about the 5 main branches. First, we have organic chemistry. This branch focuses on the study of carbon compounds. Carbon is a special element that can form millions of different compounds, which are the building blocks of all life. Next is inorganic chemistry. This deals with the study of all the other elements and compounds that don't contain carbon. Think metals, minerals, and salts. Then there's physical chemistry. This is where chemistry meets physics. It's the study of the physical properties of matter and how energy changes during chemical reactions. It helps explain why reactions happen and how fast they go. We also have analytical chemistry. This branch is like the detective work of chemistry. It's all about identifying what substances are present in a sample and measuring how much of each substance there is. It's crucial for things like quality control and environmental testing. Finally, there's biochemistry. This is the chemistry of life itself. It explores the chemical processes that happen inside living organisms, from plants to animals to us. It helps us understand things like DNA, proteins, and metabolism. Let's go back to the core concept, matter. We said matter is anything that has mass and occupies space. It's a very simple definition for something that includes everything in the universe. The desk you're at, the book in front of you, the water in your glass, the air filling the room, the plants outside, and even your own body, it's all made of matter. Matter is composed of tiny particles called atoms, which are the fundamental building blocks of everything. To make sense of all this stuff, scientists classify matter into different categories. The main way we do this is by dividing matter into three groups: elements, compounds, and mixtures. Understanding the difference between these three is fundamental to understanding chemistry. So let's look at each one more closely. First up, elements. An element is a pure substance that is made up of only one type of atom. This means you can't break it down into simpler substances by chemical means. Think of them as the basic ingredients of the universe. There are over 100 known elements, and you can find them all organized in a special chart called the periodic table. Some common examples of elements that you might have heard of are oxygen, which we breathe, hydrogen, the most abundant element in the universe, carbon, the basis of life, and metals like gold, iron, and silver. Each element has its own unique properties. Now, what happens when elements get together? They can form compounds. A compound is a pure substance that is formed when two or more different elements combine chemically in a fixed ratio. This fixed ratio part is really important. For example, water is a compound. Its chemical formula is H. This means every single molecule of water is made of exactly 2 hydrogen atoms chemically bonded to 1 oxygen atom. If you change that ratio, it's not water anymore. Another example is carbon dioxide CO, which we exhale. It's always 1 carbon atom bonded to 2 oxygen atoms. Table salt or sodium chloride. Sodium chloride is another common compound formed from 1 sodium atom and 1 chlorine atom. Unlike elements, compounds can be broken down into simpler substances, their constituent elements, but only through a chemical reaction. So we have elements and compounds. What's the third category? Mixtures. A mixture is formed when 2 or more substances, which can be elements or compounds, are combined physically but not chemically. The key difference here is physically combined. This means the individual substances in a mixture keep their own identities and properties. For example, if you dissolve salt in water, you get salt water. It's a mixture. The water is still water, and the salt is still salt. A huge advantage of mixtures is that because they are only physically combined, they can often be separated by simple physical methods. You could boil the salt water to evaporate the water and leave the salt behind. Air is another great example of a mixture. It's mostly nitrogen and oxygen gases, with small amounts of other gases, all just mixed together. Mixing sand with iron filings is another classic example of a mixture. You can easily separate them using a magnet, which pulls out the iron filings but leaves the sand. Finally, let's talk about the changes that matter can undergo. We group these into two types: physical changes and chemical changes. A physical change is a change in the form or appearance of a substance, but it does not produce a new substance. The chemical identity of the matter remains the same. A great example is melting ice. Ice is solid water. When it melts, it becomes liquid water. It's still HO, just in a different state. Other examples include breaking a piece of glass, tearing paper, or dissolving sugar in water. In all these cases, you haven't created anything new. On the other hand, a chemical change, also known as a chemical reaction, is a process that results in the formation of a new substance with new properties. The original substances are used up, and something entirely different is created. For instance, the rusting of iron. Iron reacts with oxygen in the air to form iron oxide, or rust, which is a completely different substance with different properties than iron. Burning paper is another chemical change. The paper turns into ash, smoke, and gases new substances. Cooking food is a complex series of chemical changes that alters the ingredients into a delicious meal. All right, let's quickly recap what we've covered today. We started by defining chemistry as the study of matter and its changes. We saw how chemistry is essential in our daily lives, from medicine to food. We explored the 5 main branches of chemistry: organic, inorganic, physical, analytical, and biochemistry. We then defined matter and learned how to classify it into elements, which are pure substances made of one type of atom. Compounds, which are formed when elements combine chemically in a fixed ratio, and mixtures where substances are combined physically. Finally, we differentiated between physical changes, which don't create new substances, and chemical changes, which do. Understanding these fundamental concepts is absolutely key. They are the foundation upon which all your future chemistry knowledge will be built. Thank you so much for watching this lecture. I hope you found it helpful and now have a clearer understanding of the fundamentals of chemistry. If you enjoyed this video and learned something new, please give it a thumbs up. Share it with your friends, and don't forget to subscribe to the channel for more chemistry lessons. See you in the next video.